You know, I find it rather extraordinary that we are here at all. Not in the philosophical sense, well yes, in the philosophical sense too, but I mean in the very precise mathematical sense. The universe, from its earliest moments, was tuned to a degree of specificity that is frankly staggering, and yet here we sit, on this rather unremarkable planet, orbiting a thoroughly ordinary star, in one of perhaps 2 trillion galaxies we can observe, asking the question that I think every serious physicist must eventually confront: are we alone? Now I want to be careful here because this question is often treated as if it were merely a matter for science fiction, or for romantic speculation on a clear night. It is not. It is a question with genuine physical, mathematical, and I would say deeply philosophical weight, and I want to approach it seriously today, not with the breathlessness of popular science, but with the kind of honest rigor that I believe the question actually deserves. Let me begin with what we actually know. The universe is approximately 13.8 billion years old. Our Sun formed about 4.6 billion years ago, but there are stars in this galaxy that are 2, 3, even 4 times older than our Sun. The galaxy itself, the Milky Way, contains somewhere in the region of 2 to 400 billion stars, and from what we now understand about planet formation, the majority of those stars host planets. Many of those planets sit in what astronomers call the habitable zone, close enough to their star for liquid water, not so close as to boil it away. Now you might think, well, with numbers like that, surely the galaxy must be teeming with life, and this is essentially the argument behind what's called the Drake equation, which Frank Drake proposed in 1961. It was a rather elegant way of framing the problem: a string of probabilities multiplied together, the rate of star formation, the fraction of stars with planets, the fraction of those planets that could support life, and so on, all the way down to the fraction of those civilizations that might actually be detectable. The trouble, and I think this is a trouble that hasn't been taken seriously enough, is that most of those terms in the Drake equation are almost entirely unknown. We don't know them from observational evidence, we guess at them, and depending on how optimistic or pessimistic your guesses are, you can arrive at wildly different conclusions. There's a version of this calculation that suggests thousands of communicating civilizations in our galaxy right now, and there's another version, rather more sobering, that suggests we might be the only ones. Both are mathematically consistent with what we currently observe. That's not a satisfying state of affairs for a physicist. Which brings me to what I think is the really profound difficulty, and it was first put so memorably by Enrico Fermi at that lunch in Los Alamos in 1950. He looked at the numbers, at the age of the galaxy, at the seemingly reasonable likelihood of intelligent life arising elsewhere, and he said, apparently in a rather offhand way, which I find rather appealing, "Where is everybody?" That simple question has become known as the Fermi Paradox, and it has never really been answered. The galaxy is old enough that even a civilization only slightly more advanced than ours, moving at a small fraction of the speed of light, should have had time to colonize the entire galaxy many times over. And yet silence. No signals, no visitors, no evidence. Now I want to tell you that I don't find this silence comforting. I find it puzzling, and I think it's important to sit with that puzzlement rather than explain it away too quickly. So let us ask the question directly: what if they arrive tomorrow? Not metaphorically, not as a thought experiment tucked away in a footnote. What if, tomorrow morning, something arrived, something unambiguously non-human, unambiguously intelligent, and unambiguously here? The first thing I'd want to know, and I think this tells you something about how a physicist approaches these things, is how did they get here? Because the physics of interstellar travel is genuinely profoundly difficult. The nearest star to us is Proxima Centauri, roughly 4.2 light-years away. With the most advanced propulsion technology we can currently conceive of, I mean genuinely conceive of, not merely fantasize about, a journey to the nearest star would take thousands of years. To travel at a significant fraction of the speed of light requires energy on a scale that is at present utterly beyond us. Now if they arrived tomorrow, they would necessarily have solved a problem we haven't even properly framed yet. Either they have mastered energy generation on an astronomical scale, or they have found some way of bending the geometry of space-time itself, exploiting something in general relativity that we understand in principle, but certainly cannot engineer. And the moment you say that, you realize you're talking about a civilization so far ahead of ours that the gap between them and us might be analogous to the gap between us and a bacterium. I don't mean that disparagingly, I mean it quite literally, in terms of the complexity of knowledge required. And here is where my own work becomes relevant in a way that I find both exciting and unsettling. I've spent a considerable portion of my career thinking about what I call conformal cyclic cosmology, the idea that our universe is not a unique event, but rather one aeon in an infinite sequence of aeons, each one beginning with something like what we call the Big Bang, expanding, cooling, and eventually giving way to the next. In this picture, the universe cycles endlessly, and between those cycles, encoded faintly in the cosmic microwave background, the faint afterglow of the Big Bang that we can actually observe and measure. There may be traces, what I call Hawking points, left by black holes from a previous aeon. Now I want to be very clear, I am not claiming we have found alien messages in the cosmic microwave background. What I am saying is something rather more subtle, and I think rather more interesting. If CCC is correct, and I believe there is genuine observational evidence for it, though my colleagues have not all agreed, then the universe has the structure of a kind of deep time that dwarfs anything we normally contemplate. We're not talking about billions of years, we're talking about structures of time that make a billion years look like an afternoon. And in that kind of deep time, the question of whether intelligence has arisen before, not just elsewhere in this aeon, but in previous aeons, becomes something one can at least pose as a mathematically coherent question. In 2015, my colleague Vahe Gurzadian and I wrote a paper specifically examining the Fermi Paradox in the context of CCC. The point was this: if information can be transmitted from one aeon to the next, encoded in patterns in the cosmic microwave background, then the idea of communication from remote civilizations takes on a new dimension entirely. We're not just asking whether a civilization on some distant planet might send us a radio signal. We're asking whether intelligence from a previous universe might have embedded information in the fabric of this one. I want to be honest with you. This is highly speculative. I believe it is consistent with the physics, but I hold it lightly. What I do not hold lightly is the underlying point, which is that our usual ways of thinking about alien contact are almost certainly too narrow. We imagine radio telescopes, we imagine signals at the hydrogen frequency, we imagine a signal that we'd recognize as a pattern, something like prime numbers, because prime numbers are mathematical, and mathematics we assume is universal. These are reasonable things to look for. The SETI program has been running for decades, and I think it is worth doing, but I would be surprised if first contact, if it comes at all, comes in the form we expect. Here's why. The civilizations we might encounter, if we encounter any, would almost certainly either be very far behind us, or very far ahead, and very far behind means they're not contacting us. The interesting case, the only case that results in contact, is a civilization sufficiently advanced to traverse interstellar or intergalactic distances, and a civilization capable of that is by any reasonable estimate millions or perhaps billions of years more advanced than we are. I think of this sometimes in terms of something called the Penrose process, though I should acknowledge it's a little immodest to mention one's own work in this context. Back in the late 1960s, I described a mechanism by which energy could in principle be extracted from a rotating black hole, from the ergosphere, that outer region of the black hole, where space-time itself is dragged around by the rotation. The amount of energy involved is enormous by human standards. I noted at the time that only a very highly advanced civilization could ever hope to harness this mechanism, and my colleagues at Glasgow recently demonstrated the underlying physics of this, using sound waves, in a rather clever laboratory experiment, which I found very gratifying. The point is, a civilization advanced enough to exploit black holes for energy, a so-called Kardashev Type 2 or Type 3 civilization, would be operating at scales we can barely imagine. And when we ask what it would mean for such a civilization to arrive here tomorrow, we have to confront the possibility that our frameworks, our physics, our mathematics, our very concepts of communication and intention, might be as inadequate to the task as a medieval monk's framework would be for understanding the internet. Now, let me come to a question I am sometimes asked, which is whether I think they would be friendly. And here I have to say something that may surprise you. I think the question, phrased that way, might not even be coherent. We project onto hypothetical alien intelligence the assumption that they would have interests, motivations, desires, in anything like the sense we do. But if you think seriously about consciousness, and I've spent a large part of my career doing precisely that, consciousness in our own case is the product of a very particular set of physical processes. My own view, developed with the anesthesiologist Stuart Hameroff, is that consciousness involves quantum processes in structures called microtubules inside neurons, and that it requires something beyond what we currently understand in physics, something I call orchestrated objective reduction. I hold this view with some conviction, though I acknowledge it is controversial. But the deeper point is this: if consciousness in human beings arises from a very particular physical substrate, then it need not be replicated in anything like the same form in another species, on another world, that has evolved under completely different conditions. Their experience of the universe, if they have experience at all in any meaningful sense, might be so profoundly different from ours that the question of whether they are friendly is like asking whether a star is friendly. It is not that they would be hostile, it is that our categories might not apply. And yet, and this is something I come back to repeatedly, mathematics would apply. This is one of the most remarkable features of the universe that I know of, and it has been remarked upon by many others, but I don't think it has been sufficiently absorbed. The physical universe obeys mathematical laws, not approximately, not as a useful metaphor. The deep structure of space-time is genuinely, rigorously mathematical. The geometry of a black hole, the behavior of quantum fields, the expansion of the universe, all of these are described by mathematical structures of extraordinary precision. And if another civilization has arisen anywhere in this universe, they have arisen in the same universe, subject to the same mathematical laws. They would know about prime numbers, they would know about general relativity. They would know, if they looked carefully enough, about the Riemann hypothesis, about the Gödel incompleteness theorems, about Penrose tilings, though perhaps they would have discovered these things under very different names. This mathematical universality is, I think, our best hope for any meaningful exchange, and it is why I believe that if contact ever happens, mathematics will be the bridge. Now let me say something about what I think the actual probability of contact is, because I don't want to be evasive on this point. My honest view is that while other intelligent life may well exist somewhere in the universe is, after all, extraordinarily large. The probability that we will encounter it in any meaningful way seems to me quite low, and I say this not from pessimism, but from taking the physics seriously. The distances involved are almost literally incomprehensible. Even at the speed of light, a signal from a civilization, 1,000 light-years away, which is not very far by galactic standards, takes 1,000 years to reach us, and 1,000 years to carry a reply. By the time a conversation completed, even a single exchange, civilizations rise and fall, and the speed of light is not merely a practical limit. It is, as far as we can tell from general relativity, a fundamental feature of the structure of spacetime. There is no credible physics that allows you to exceed it without incurring paradoxes so severe that the framework collapses. Unless, and here I am genuinely speculating, I want to be clear about that, unless the geometry of spacetime permits something we haven't yet understood. There are solutions to Einstein's field equations that allow for things like wormholes, regions where spacetime connects two distant points in a way that permits faster-than-light travel in some operational sense. These are mathematically consistent. They may or may not be physically possible. The cosmic censorship conjecture, which I myself proposed, concerns singularities and the way nature seems to hide the most extreme violations of predictability inside black holes. We don't yet know whether nature similarly censors the more exotic geometries that would allow wormhole traversal. These are open questions, genuinely open. So when I try to answer the question, what would it mean if they arrived tomorrow, I find myself in an unusual position for a physicist. The honest answer is it would mean that there is physics we don't know, not a small correction to existing physics, not a refinement, a fundamental revision, because nothing in our current understanding of the universe permits that kind of travel from any distance beyond our immediate cosmic neighborhood in any reasonable time frame, and that, paradoxically, is what makes the question so important. The arrival of a genuinely alien intelligence would not merely be a zoological curiosity, it would be a revolution in physics. It would tell us with certainty that general relativity, as we currently understand it, is incomplete, which I should say I already believe, for other reasons having to do with the tension between general relativity and quantum mechanics. These two great theories of the 20th century are at their deepest level inconsistent with one another. We do not yet have a theory that reconciles them, and a civilization that had learned to navigate between stars would have had to solve that problem. I want to close with something that I think is often overlooked in discussions of this kind. The question of whether we are alone in the universe is not merely a scientific question. It is a question about the nature of mind, and the nature of mathematics, and the nature of physical law. I have spent my career arguing that consciousness cannot be reduced to computation, that the human mind does something that no Turing machine can replicate, because it requires the kinds of non-algorithmic insights that Gödel's incompleteness theorems point toward. I believe genuine mathematical understanding is not something that can be captured in a program. And if that is true, if consciousness requires something beyond mere computation, something perhaps tied to the fundamental physics of the universe in ways we don't yet understand, then the question of whether that kind of consciousness could arise elsewhere becomes not just a question about biology, but a question about whether the universe in some sense tends toward mind. I don't know the answer to that. Nobody does. But I find it to be among the most magnificent questions I know of. If they arrived tomorrow, we would be forced to confront all of it at once. The physics of travel, the nature of mind, the structure of mathematics, the depth of time. We would have to revise our picture of the universe, not at the edges, not in the fine print, but at the very center. And speaking only for myself as a mathematician, as a physicist, as someone who has spent his life trying to understand the deep structure of reality, I think I would find that rather wonderful. Thank you.